Welcome back to Math Teacher Institute. Today we're going to talk about this weird thing of how pre-calculus doesn't really have any calculus in it, but it can. Come on in. Hi, I'm Maher Dalal and this is Math Teacher Institute. I've been a math teacher all over the world and I have a master's degree from the Math for Teaching program at Harvard. If you love math and love teaching math to others, this is the place for you. Pre-calculus is kind of a weird name for a course that comes after an Algebra 2 course and before a calculus course, because it sounds like a course that should introduce you to calculus, but it really doesn't. It's really more of an Algebra 2.5 or an extended Algebra 2, but with trigonometry added in, and then it's like they had some extra stuff that we had forgotten to cover, like matrices and vectors and parametric and polar equations, and they decided, well, throw all that stuff in there too while we're at it, and we'll just, cross off everything before we get to calculus. So it's kind of a strange name for a subject that doesn't really have much, even a hint of calculus in it. So today I'm going to tell you about 3 ways that we can incorporate a little bit more calculus into our pre-calc class in a nice organic way that will benefit your students not only as pre-calc students, but eventually when they move on to calculus as well. The first way that we can incorporate some calculus into our pre-calc class is when we're studying horizontal asymptotes and rational functions. Now, as you know, horizontal asymptotes are essentially just the limit as x approaches infinity or negative infinity of a rational function. And in fact, the rules that we teach with the ratio of the coefficients based on the powers and all those rules, those are the same rules for horizontal asymptotes as they are for limits at infinity. We teach the same rules. So when we're teaching this in pre-calc, all we have to do is decide to use limit terminology at the very least when we're discussing it with our students. Instead of using these kind of awkward x arrow infinity y arrow 3 kind of notation that isn't real math notation, we all know that. It's just something that I guess text companies came up with a while ago. You can see all these examples of textbooks that use this notation, but it's not real math notation. Limit notation is real math notation. And there's really no reason why our students can't understand the notation if nothing else, right? So even if we don't want to get into a long discussion of what limits are and what it really means, we can certainly use the notation and at least prepare our students for what they're going to see when they get to calculus. Now, I would certainly push for a little more than that, and I would actually go into just a very basic discussion of what a limit is. As x approaches infinity, as x gets larger and larger, what y values are our function approaching? Doesn't matter what they reach. What do they approach, right? And that value that our function is approaching as x gets larger and larger is our horizontal asymptote. One other note on horizontal asymptotes that I think is really helpful, not necessarily calculus related, but really has helped my students is, when I talk about horizontal asymptotes, I call them end behavior asymptotes. Students struggle with the idea that vertical asymptotes are absolutely cannot be crossed kind of walls, and horizontal asymptotes can. And so when I talk about them as end behavior asymptotes, I tell them, look, they matter at the ends. They don't really matter in the middle, because they're not middle behavior asymptotes, they're end behavior asymptotes. And a lot of times that really suddenly turns on the light bulb, my students understand, it makes sense to them, and everything seems to get better a lot quicker. So just a little extra bonus tip for you guys. The second way that we can incorporate a little bit of calculus into our pre-calc classes is when we're graphing sine and cosine. We may not want to talk about the fact that cosine is the derivative of sine, okay, or what derivatives are at all with a pre-calc class, but we can start to point out some of the connections between those two functions and show students that, for example, the minimums and maximums of sine happen at the points where cosine has a 0. And there's that relationship. If you want to even get a more fancy, the zeros of sine have a slope of 1 or negative 1, and they match up with the minimums and maximums of cosine, right? So we can start to help our students see that there's some sort of a relationship between the slope of one of these functions and the values of the other function, even if we don't want to talk about what a derivative is or talk about that they're derivatives of each other. That connection, that idea that, there's something about the slope here and the values here that are connected to each other is a valuable idea that will benefit them when they move on to calculus. The third way that we can talk about calculus a little bit more in our pre-calc classes is to introduce the idea of convergence and divergence when we're talking about sequences and series. We talk about series that maybe have a sum that's infinity or a series that goes to infinity, but we don't use that terminology very often. And it's relatively simple terminology to understand. If the sum is finite, then we say it's convergent and we give the sum. If the sum is infinite, then we say it is divergent, right? But introducing that calculus terminology into our pre-calculus classes will help us to bridge that gap just a little bit better between pre-calculus and calculus, which is a difficult bridge for a lot of students to cross. I also want to point out that there's a very fundamental difference between the skills needed to be successful in pre-calculus and the skills needed to be successful in calculus. Pre-calculus, in my opinion, is sort of the pinnacle of algebra. It is the most intense, rigorous, difficult algebra that you're going to do as a high school student. The problems are long. They require tons of different techniques. We got to factor this, and then we're using trig identities, and then we're going to cancel this, and then we have to do inverse trig. Oh my gosh, there's just so much work associated, right? None of the problems in pre-calc are particularly cerebrally difficult to understand, but algebraically, computationally, they are extremely labor intensive and difficult. Calculus is a total shift. Calculus is very cerebral, right? Finding the answer to a calculus problem is not about bashing out tons of work normally. It's normally about understanding the right setup, understanding the right approach. It's much more cerebral, much less brute force. So it's a big change from what pre-calculus is like. And so I try to highlight this to my students at the beginning of the year, for better or for worse. Sometimes I have students that are extremely strong in the computation side, and this is a little bit of bad news for them because they were hoping to rely on those skills in calculus, and it's good to let them know that you may not be able to rely on those skills as much as you have in the past. And also to encourage some students that maybe struggled with some of those really labor-intensive problems that, hey, you can rely a little bit more on your cleverness, a little bit more on your conceptual understanding in calculus, and you don't have to rely as much on just bashing out really long, intense problems every single time. If you have a unique or interesting way of incorporating calculus into your pre-calc class, please share it with us in the comments below. Or if you have any questions about a particular pre-calc lesson that you'd like me to address in a future video, you can post that below as well.